Hi, everyone. I wanted to do a video on a little bit of organic chemistry for review. Main thing I want to focus on is drawing organic molecules and naming them. Okay. Let's first talk about drawing organic molecules. Organic molecules are written in an abbreviated form. If we were to write a 4-carbon hydrocarbon like this, we'd write 4 C's, and then we have to write the associated hydrogens around it. And hydrogens are the most abundant element in the universe, so we'd be writing hydrogens all day long. So organic chemists and biochemists have abbreviated that to this form here, where we have eliminated the hydrogens because we know that carbon is sp3 hybridized. So that means it's got 4 bonds, not 2. We wrote the standard electronic configuration orbitals. We'd have 2 singletons. That means we could bond twice. However, once we hybridize, we end up with 4 singletons. We hybridize the S, the 2S, and the 2 Ps to form 4 singletons, meaning we can bond 4 times. sp3 hybridization. Okay, now, by the way, there's also sp2 and sp hybridization as well. This is a double bond, single bond, or a triple bond. Okay, so the way we abbreviate the structure drawing is we eliminate the H's, number 1, and we eliminate the C's. So we would draw this 4-carbon butane, this 4-carbon hydrocarbon like this instead of with all the H's. Whenever we signify a carbon, we would signify it at the beginning and at the end, and every time we had a change of direction. So we go 1, 2, 3, 4. So 1 is the beginning, 2 and 3 are changes in direction, 4 is the end. Now, biochemists do the same thing. For example, glucose looks like this. That would be alpha glucose. And again, notice there are no C's there, and there are no H's there. So both organic chemists and biochemists don't do the H's or the C's. Okay. If we were to write C6H14, we'd go 1, 2, 3, 4, 5, 6. If we do a cyclic C6H12, we would start. Doesn't matter where we started counting, we go 1, 2, 3, 4, 5, 6. Okay, so that's the way organic chemists and biochemists write abbreviated structures. Now let's talk a little about naming. Now, organic chemists name via something called the UPAC convention. And what they've done with that, they standardized naming of organic compounds. excuse me, it's IUPAC, not UPAC. It stands for the International Union of Pure and Applied Chemists. And it meets regularly, and there's tons and tons of information on how to use an official IUPAC convention naming system. Now, there's something called common names and IUPAC names. The IUPAC names tend to be a little more complicated, but they're accepted universally in an international scope. Okay. They're in three parts, these names. And there's a backbone, a functional group, and I'm going to talk to you about what the functional groups are. And then there's branches off of the backbone. And the branches are optional. Sometimes they're there, and sometimes they aren't. But for sure, you've got to have backbone the backbone, and you've got to have the functional group. Okay, so this is a subset of the functional groups. There are more, but these are the most common ones. Okay, so we have alkane, alkene, alkyne, alcohol, aldehyde, ketones, acids, and then goes esters, amines, amides. And there's probably 20 more groups, but these are the most common ones. When we name the organic compound, we have to give it an appropriate name based on the functional group, so you know what functional group we're talking about. Also, on what carbon that functional group is located. Okay, and then when we name the backbone has so many carbon atoms, and we're going to be using these prefixes: methana, ethana, propana, butana, etc., all the way to 10 that goes on from there. When we talk about the branches, one talks about how many of the branches there are, and they're either methyl or ethyl, usually 99% of the time, but there are others. These are the most common ones, methyl and ethyl. Okay, so let's get into an example of me. Okay, what I've done is I've marked in green the backbone on all these molecules, and I'm going to show you how we name it. Okay, and again, there are always three parts: the branch, the backbone, functional group. Okay, so this particular molecule has got an aldehyde at the end, a double bonded oxygen. Double bonded oxygen, and there's a hydrogen there, and aldehydes are always at the end. And to complement that, the ketones are never at the end. So we always study those together because their chemistry is very, very related. Okay, so this is an aldehyde, and it's on the end, and we're using the Al postscript, indicates an aldehyde. It's got a 4-carbon backbone, 1, 2, 3, 4. The functional group aldehyde starts at carbon number 1. Now, there's two ways to number this. We can start on the left at 1 or on the right at 1. So whenever we have a functional group, that defines the numbering. So the backbone consists of 4 carbons. That means we're going to use the butana. The functional group is an aldehyde, so we're using the Al. And there is a branch at carbon number 3. And that branch is a methyl group because it only has 1 carbon now. So it's on carbon number 3. So it's 3-methyl butanal. Excuse me. So 3-methyl butanal. And that's basically how you name stuff. More examples here. Okay, we got a 3-carbon backbone, and we have a ketone. So the ketone takes on the ONE functional group. And notice it's not at the end, it's in the middle. It's a 3-carbon backbone. And we have no branches. So it's just going to be propanone. Propa, because it's 3-carbon backbone. ONE, because it's a ketone. No branching, so it's going to be propanone. The 2 is optional because the only place the ketone can be is on carbon number 2, because it has to be in a non-end. So the only non-end carbon is carbon number 2. So frequently they'll leave off the 2. I usually tell students to put it on so it's consistent. Let's look at another one. Okay, this is a 4-carbon, and it's an organic acid. It's got a branch, a methyl branch. The carbon number 2, 1, 2. And remember, we can always number the backbone from left to right or right to left. We get whatever the functional group is, gives us the lowest number. So we go 1, 2, 3, 4, or 1, 2, 3, 4. So if we count from the right to left, gives us the functional group on carbon number 1 as opposed to carbon number 4. Okay. On the second carbon, we've got a methyl group. So, going to be 2-methyl butanoic acid. 2-butanoic acid. Then another one here. This has got multiple branching. So we've got 1, 2, 3, 4, 5, 6. Got a 6-carbon backbone. We've got the functional group is just an OH, which is an alcohol functional group, on carbon number 1, 2, 3. So we have 1, 2, 3, 4, and 5 are the 2 methyl groups. So that's going to be 4, 5, di, meaning 2, methyl, 3, hexanol, 4, 5, dimethyl, 3, hexanol. And that's all there is to naming. Now, what they wanted me to do on this OChem review is to go over naming and drawing organic compounds. Let's do one more as an example. Let's do let's do this one here. Now this has got okay, that's the backbone. It's cyclic in this case. Six-carbon cyclic. It's got an alcohol functional group, and it's got a methyl branch. So the backbone is going to be cyclohexanol, because of the alcohol. And the alcohol is going to be at carbon number 1. And that means the methyl group is on carbon number 2. So I need 2-methyl cyclohexanol. Okay, and this is just a matter of doing a lot of practice and getting used to this number. I recommend using a highlighter for the backbone. And you can use a different color for the functional group and the branching. My students tend to like to use highlighters.